So what we'll do is we'll continue with coordinate geometry where we left off, right?
Yeah.
And I hope you have some exercises, doubts, and all. If you have any issues in any
Yeah.
of this, can you tell me?
In eighth one.
Eighth one.
Yeah.
Hmm.
36.
Eighth one, 36.
Yeah.
Okay, wait. Okay. One side of a square, this one, no? Correct. One side of a square is inclined to the axis. Okay. Question exercise 8, question 36. SL Loney. Okay. So the question says that you can hear me clearly, no?
Yeah.
Okay. One side of a square is inclined to the x-axis at an angle alpha. Let's draw a rough figure. Y,
Yeah.
x. So maybe one side is like this. So this angle is alpha. So the square will be something like this, right?
Yeah.
Okay. This is 90 and all. Okay. And one of its extremities is at the origin. So this is 0, 0. Prove that the equations of its diagonals, you have to find the equation of the diagonals is
Yeah.
this and this. So both the diagonals equations you have to find. And what is given is length of the side of the square is A. Okay. Okay. So that's it, right? Length of the, okay. So, okay. So how will we go about finding this, right? This point,
Yeah.
this vertex, can you find this vertex? This is A sine alpha comma A cos alpha, right? No, I'm making a mistake. A cos alpha
Yeah.
comma A sine alpha.
Yeah.
Correct. So,
Yeah.
okay. Now we have found that vertex. Then angles, we need some slopes. Let's call this diagonal 1, this one, and this is diagonal 2.
Yeah.
Okay. So, okay. So we have to find slope of 1, no? Because equation of diagonal 1 will be y minus 0 is equal to m into x minus 0, right? It is passing through 0, 0, no?
Yeah.
So we just need the slope of this angle line, right? Correct. So
Yeah.
diagonal of a square bisects each other. So this is 45, right?
Yeah.
Diagonal of the square will bisect this angle. So the overall angle with the x-axis for this line is 45 plus alpha, right? This is the
Yeah.
theta. So the slope will become tan theta is equal to 1 plus tan alpha by 1 minus tan alpha. Are you getting how? Tan of 45 plus alpha, right?
It's on. Yeah.
Correct.
Yeah.
So cool. So now equation of the line we have gotten y is equal to 1 plus tan alpha by 1 minus tan alpha into x, right? Correct.
Yeah.
So
Yeah.
does it make sense? This is fine, no? And
Yeah.
equation of the other line, diagonals of a square are perpendicular to each other, right? Correct.
Yeah.
So slope of the other line is minus 1 by slope of this line, right? Makes sense?
Yeah.
So slope of the other line is definitely going to be equal to m1 is equal to 1 minus of 1 minus tan alpha by 1 plus tan alpha, right?
Yeah.
And we also know that the other line passes through this point, a cos alpha, a sin alpha. So equation of the
Yeah.
other line will be y minus a sin alpha is equal to m, which is tan alpha minus 1 by tan alpha plus 1 multiplied by x minus a cos alpha, right? This is the other
Yeah.
line. This is line 2. Correct?
Yeah.
So this is how you find the equation of the diagonals what you do basically is you find out vertices, one vertex here and one vertex here. This
Yeah.
was already known, this was known. Now you are finding the slopes. The slope was, the angle was 45 plus alpha. So slope would be tan of that. So tan of this is becoming this, right? And after that, you just
Okay.
write the equations. And the diagonals of a square are perpendicular to each other. Diagonals of a
Okay.
square are perpendicular to each other. Okay. Okay.
Yeah.
Next.
42.
Question number 42. Find the equations. Find the equation to the bisectors. Equation to the equation of the bisectors of internal angles of the triangles.
Yeah.
Internal angles of the triangles formed by equations. The equations of the sides are given. So one side is 3x
Yeah.
plus 4y is equal to 6. The other
Yeah.
side is 12x minus 5y is equal to 3. And another side is
Yeah.
4x minus 3y plus 12 equal to 0. Right? Okay.
Yeah.
So we have to figure out the equation of the internal angle bisectors, right? So
Yeah.
we have to, okay. So one way to do it would be to find the coordinates of the triangle, right?
Okay. Yeah.
Like suppose this is A, B, C. Let's say this equation is 3x plus 4y is equal to 6. This equation is AB, BC. So this equation is 12x minus 5y is equal to 3. This equation is 4x minus 3y plus 12 is equal to 0. Right? Correct.
Yeah. Yeah.
Uh, then, okay. Then we will find basically each point, right? We can find each point here, right? Now,
Yeah.
to decide whether the bisector, now if you have this bisector, you can find one equation of bisector like this and one equation like this, right?
Yeah.
Correct. So
Yeah.
you have to decide which bisector you have to get, right? That is the point.
Yeah.
So like basically which, whether this equation is plus or minus, right? You need only this
Yeah.
one. You need this one, whether it is plus or minus, right? Okay. So
Yeah.
if you draw two bisectors, right? This point is
Yeah.
in center, no? This point is in
Yeah.
center. So in center is always inside the triangle, right? Okay, so
Yeah.
let's just find in center, no? And in the bisector equations, we'll put and check whether it lies on the bisector. You understand what I will do? So what I will do
Okay.
is I will find in center also. Okay, if I find in center,
Yeah.
then what I will do is in the two options that I get from the bisector equations, it is different by plus and minus. No, there will be something like this: c1x
Yeah.
plus b1i plus c1 by root a1 square plus b1 square
Root A1 square plus
is equal to a2x plus b2y plus c2 by root a2 square plus b2 square, right? Now the
Yeah.
problem is that there is a confusion whether the internal bisector is the one with the plus sign or the minus sign, right? So
Yeah.
how can we resolve that confusion? We can resolve that confusion by taking both the equations and seeing whether in center fits that equation or not, right? In center only lies on
Okay.
internal angle bisector, right?
Yeah.
You understand?
Yeah.
In center cannot lie on the external bisector, no?
Yeah.
So then you will be able to distinguish which sign is correct, right? So let's
Yeah.
just do this question for a specific case. So let's first find a point. A is the intersection of this line and this line, right?
Yeah.
So if you solve it, you'll solve it by multiplying 3 and 4, right? So this will become 4x,
Yeah.
12x plus 16y is equal to 24. 12x plus 16y is equal to 24. And this will become 12x minus 9y is equal to minus 36, right? And then you subtract.
Yeah.
So it becomes 25y is equal to 60. 60. So this becomes y is equal to 12, 5 say 12 by 5, right? Y is 12 by 5.
Yeah.
So x is equal to 4x is equal to 3y minus 12. So 36 by 5, 3y minus 12. So 36 minus 60, so minus 24 by 5, minus 6 by 5. A is coming minus 6 by 5, comma 12 by 5, right?
Okay.
If you solve the vertices, this is coming, and B will come uh, 2 by 3, comma 1. If you solve it, it will come, okay? And C comes
Yeah.
as
Okay.
33 by 8,
Yeah.
comma 39 by 4. C comes as this. A, B, C you have gotten, okay? So,
Okay.
equation of bisector, the two equations of the bisectors you can immediately write, right? Correct?
Yeah.
Two equations of the bisector you can immediately write. Now, the problem is that the incenter becomes a horrible point. That is what I am suspecting is the problem. You understand? Right now, if I have three
Yeah.
vertices, I can find incenter by this formula, no? A into x1 plus b into x2 plus
Yeah.
c into
B into
x3
plus
by
C
a
into
plus b plus c.
by A1. Yeah.
A y1 plus b y2 plus c y3 by a plus b plus c. We
B
know
plus
this.
C.
This was
Yeah.
derived in the previous section only, right? Correct?
Yeah.
So this a, b, c had lengths of the sides here, right?
Yeah.
The problem is that the lengths of the side are coming out to be horrible numbers, right?
Yeah.
That is the issue. Length of the side is coming out to be horrible numbers, so I don't want to do the calculations. So question of the bisector, is there any alternate way to do? Did you understand that we can actually solve the problem if we use calculators and all?
Yeah.
Right?
Yeah.
Because distance formula will give me ABC, right?
Yeah.
Sure, no? Convinced.
Yeah.
ABC is obtained and x1, x2, x3 are known. So in center point can be found out, right?
Yeah.
And once in center point is found out, in center lies on the internal bisector only. So you can put this in these equations, this point, and you can check whether plus is satisfying or minus is satisfying, right? Correct?
Yeah.
So that is one way to do it. Let's
Yeah.
think of some other way, because I don't want to do that calculation. Okay. So let's think. Uh, hmm, internal angle equation whose sides are given. So
Sir, what if we take any point inside the triangle and then check?
that is correct. But which point will you check? Check, that is the thing. Which point will you check? No, that is the point. If you take inside the triangle, then all three should, so it should be below this line, and it should be below this line, and it should be above this line, right?
Yeah.
Something like that should happen. So I will just give you a working rule for this. Suppose this is the thing. This is the line. This is line 1, line 2, line 3, right? And you have to
Yeah.
find internal angle bisectors, right?
Yeah.
So the rule is find the points A, B, C. find the points A, B, C. So first, find vertices A, B, C by solving for line 1 and line 2, right? You're getting intersection points, right? Then
Yeah.
once you have found A, put A into the opposite side. Put A in the equation of L3. Okay, put A in the equation of L3. If the result can be negative or it can be positive, right?
Yeah.
It will either be negative or positive, right? So if the result
Yeah.
is negative, then multiply the equation of L3 by -1,
Okay.
and if the result is positive, then multiply it by +1. Multiply L3 by +1.
Yeah.
Okay.
In the first rule, like the last sentence, what is that? Like L1 and that inverted U L2?
Intersection.
Okay.
So this is the first step. This is the second step. So you are saying that I will solve all the vertices by doing L1 intersection L2, similarly L2 intersection L3,
Yeah.
and so on, right? Then
Okay.
put A and similarly put B. Put A in the equation of the opposite side. Okay. And
Yeah.
once you put that in the equation, it can come negative or positive. If it is negative, multiply the L3 by -1. If it is positive, leave it as
Okay.
it is, right?
Okay.
So B also, I will put it into L2. B,
Yeah.
I will put it in L2, right? If it is
Yeah.
negative, I will multiply L2 with -1, and if it is positive, I'll multiply L2 with 1 or nothing. I'll do nothing, right?
And you keep on doing that till for C as well.
So for C also you do. So now your line equations L1, L2, L3 will become L1 dash, L2 dash, L3 dash. Okay. Now
Okay.
it might be the same equation or it will be negative of that, right?
Yeah.
It might be the same equation or it might be negative of that. Then third step is once you have done all this, so now equation of bisector will always be
Yeah.
the the one with the positive sign, of the two bisector equations. But here you will use which lines? You'll use these lines.
Okay.
Use L1 dash, L2 dash, and L3 dash instead of the original L1, L2, L3. Now this rule I have told you on the basis of looking at the answer and seeing what is working. Okay. So
Okay.
we have to figure out why exactly it will happen is I think it has got to do with the sign of the thing, right? So um, equation of this bisector, I mean internal bisector
Yeah.
will always be the plus sign one. So
Okay.
let's think of why. Okay, so suppose instead of L3 we had L3 dash, L1 dash, and L2 dash. We have already done the changes, right? Okay. In step
Yeah.
2, we are changing the equation slightly, right? So we have already done all the changes. Okay. Okay. So now the equations have become something else: L1 dash, L2 dash, and L3 dash, right? Right.
Yeah.
Now these equations are such that if you put A on it, right, you get positive answer, right?
Yeah.
So A is above B, above L3, and B is
Yeah.
above. Like technically, this is not the figure, but all
Yeah.
of them are giving positive, right? So
Yeah.
then the rule is saying that the bisector will be the positive sign bisector.
Yeah.
So
Okay.
let's just check it on an equilateral triangle. No?
Yeah. So 1 minute, I'll just copy it down.
Okay. Okay, I'll go back. Wait. Okay. So this is the steps for making the bisector, internal angle bisector of a triangle.
Yeah.
This I'm getting by the answers. By looking at the answers, this is what is happening. So now at least let's check the question and verify whether the question, the answer we are getting or not. Okay.
Yeah.
So you have written down the steps, no?
Yeah.
Okay. So let's see. In our question, we had a point had come as minus 6/5, comma 12/5, and B point had come as 2/3, comma 1, and C point was 33/8, comma 39/4, right? And the equation of the sides was lines was AB was 3x plus 4y is equal to 6. BC was 12x minus 5y is equal to 3, and CA was 4x minus 3y plus 12 equal to 0. Right?
Yeah.
Correct. Now, if you substitute A you will substitute in which side? BC side, right?
Yeah.
A is opposite BC, so you'll get minus 72/5 minus 5 into 12/5 minus 3. So negative you're getting, no? So
Yeah.
negative thing you're getting. So multiply BC equation by minus 1. So 5y minus 12x is equal to minus 3.
Yeah.
So your equation has become 5y minus 12x plus 3 is equal to 0. This is your new line equation, right?
Yeah.
And let's do B on CA. B point on CA, we'll get 4 into 2/3 minus 3 plus 12. It is positive. So B is unchanged. This line is unchanged. 4x minus 3y plus 12 is equal to 0, right? And let's do C
Yeah.
on this one. So 3 into 33/8 plus 4 into 39/4. This is clearly positive, so unchanged,
Yeah.
right? So this equation is also 3x plus 4y minus 6 is equal to 0, right? So now
Yeah.
angle bisectors will always be with the plus sign. So let's check the bisectors. The bisector of AB and BC, right, will be 3x plus 4y minus 6 by root 5. So 5 is equal to plus of 5y minus 12x plus 3 by 13, right? This becomes
Yeah.
39x plus 52y minus 78 is equal to 25y minus 60x plus 15. So it becomes 99x plus 27y and minus 93, right, is equal to 0.
Yeah.
Divide by 3. So 33x plus 9y minus 31 is equal to 0. So this is one bisector. 33x plus 9y minus 31. So see, that is one of the answers is matching. This is correct. Bisector of angle B. Right?
Okay.
All the answers will match. Okay. So this working rule is going to be useful. And so, but actually I prefer the other explanation. It's just that it was not doable in this question. You understand? The other explanation was in center is inside, right? So I know one point that I can find. Maybe I can find, oh, why don't we do centroid? No, but centroid doesn't lie on that line. That is the problem, right?
Yeah.
Centroid is in the interior, so
The last class you had given some another method.
last class the method that I had given was for finding out obtuse or acute angle bisector.
Yeah.
That is still valid. So, but the problem is that in this triangles could be like this, no? So it could be obtuse also, no?
Yeah. Okay.
You understand what I'm saying?
Okay.
So in a triangle, you cannot use the acute angle obtuse angle method, no?
Okay.
Because any type of triangle is possible, no? So that will not help us much finding out which one is acute angle, which one is obtuse angle, right?
Yeah. Okay.
Because triangle could have some obtuse angles.
Yeah.
You understand? That was a method
Yeah.
for finding slope. So taking slope of this, and saying angle between them. If angle between them is greater than 90, right?
Yeah. Then
Right.
slope will be greater than 1.
So then this angle slope will be greater than 1, right? So tan
Yeah.
of alpha is equal to m minus m2 by 1 plus mm2 would be mod of that would be greater than 1 if this was
Yeah.
obtuse angle, right? And it will be
Yeah.
less than 1 if it is acute angle. But in this problem it doesn't help us a lot because triangles angles could be acute or could be obtuse, right?
Yeah.
Okay, so bisectors can be confusing because you have to decide the plus and minus sign. We know two things now: obtuse and acute angle bisectors. How to do acute angle bisector, right? And the second thing we know is if there is a triangle, you know how to find internal angle bisectors,
Yeah.
right? This has a rule. The rule is simple: line 1, line 2, line 3. Find the 3 points. Find the 3
Yeah.
points. This. Then put it in this line. See if it is coming positive or
Yeah.
negative.
Okay.
If it is coming negative, change this line to L3 dash by multiplying by -1. If it is coming positive, leave it as it is, right? And then take
Okay.
bisectors as always positive sign. Okay,
Okay.
makes sense. Okay.
Yeah.
Let's go ahead. So this would have been a doubt for you. Then 2-3 more questions now you can solve the rest of this type, right? uh,
Yeah.
Now what else, any other questions that you have, doubts?
44
Okay,
in the same exercise.
okay,
I'm just checking whether it's the same type of question or not.
okay. 44, find the equation of the straight line passing through the foot of the perpendicular from the point hk upon the straight line this and bisecting the angles between the perpendicular and the given straight line. Okay, let's just see. Okay, let me do it on the next page. Question 44. Find the equation of straight line. So passing through the foot of the perpendicular from hk upon a straight line. So there is a straight line equation given as capital AX plus
Yeah.
BY plus C is equal to 0. Now, any line perpendicular to this line, right,
Yeah.
would be what line? This slope is minus A by B.
Yeah.
So slope
So
of the perpendicular will be B by A.
it'll be B by A.
So
Yeah.
I can write it like this: minus AX plus BY plus some constant K is equal to 0.
Yeah.
No, I made a mistake. It is BX minus AY. No, see, it should be BX minus AY plus K is equal to 0.
Yeah.
Okay. Then only slope is coming
Yeah.
as B by A. No.
Yeah.
See, I know slope here is minus A by B. So slope here has to be B by A. Right now I was making a mistake earlier, right?
Yeah.
So this is the equation of a line perpendicular to the given straight line, right? Now,
Yeah.
now this perpendicular line is passing through HK.
Fine.
You are drawing a foot of perpendicular
Yeah.
from HK to this line, right?
Yeah.
HK to this line, AX plus BY plus C, right?
Yeah.
Drawn from the point HK upon the straight line. So H comma K will satisfy this line, no? H comma K. This will satisfy this
Yeah.
line. No? So we'll get BH minus A. Okay, I should have not used K here. So I'll call it lambda minus AK plus lambda is equal to 0. Right?
Yeah.
This
Yeah.
relation is there for you. Now, you have to find equation to the straight lines passing through the foot of the perpendicular and bisecting the angle between the perpendicular and the given straight line. Okay. So, okay. So lambda you have gotten, no? Lambda is equal to AK minus BH, right? See?
Yeah.
From here only, right? So equation of my perpendicular line is equal to now bx minus ay is equal to minus lambda. Minus lambda is bh minus
BH
ak.
minus A.
So this is my new
Yeah.
equation, right? Now,
Yeah.
Equation of bisector, we have to find bisectors between the given line this and the perpendicular line, no?
Yeah.
That is what the question is saying. Find the equation of the
Yeah.
bisector of the angle between the given line and the perpendicular line, right? So bisectors will be
Yeah.
just ax plus by plus c by root of a square plus b square is equal to plus minus.
Can't we take two separates, like what do you, two separate equations, because we have to find like obtuse and acute bisector. Like,
I mean, this is two separate equations only, no? Plus and minus.
no, okay.
You don't have to find specifically which one is which one. You have to find both the equations, right?
So
The question is not asking you to tell me which one is acute and which one is obtuse, right?
okay.
The question is just asking for the bisectors, which is easy. Cancel this out. This becomes a ax a minus plus b x plus b minus plus becomes plus minus a y plus c minus plus ak minus bh is equal to 0, something like this. You can write two separate equations. No, it's not very hard.
Yeah.
Right? So
Yeah.
I mean, just separate it out and write it separately. Two equations you have already gotten, right?
Yeah.
So the question was just a little confusing because of the perpendicular line and all. Otherwise, it was not so difficult. Nothing difficult is being asked here.
Yeah. Okay.
How did we get the equation of the perpendicular line? We said that it passes through h comma k and the slope is this.
Okay.
Slope is b by a because of the perpendicularity, and as soon as you got the slope, then you already know the equation is bx minus ay plus some constant. So because it passes through a, then it works out very nicely, right? Because it passes through hk.
Yeah. Okay.
Okay, next one.
In that example 10.
Exercise 10, right? Yeah.
Yeah.
Tell me.
First question.
Okay, wait. Exercise.
Yeah, 1 minute.
Correct. Exercise 10. First question. Okay.
Yeah.
Okay. So first question is saying a straight line is such that the algebraic sum of the perpendiculars let fall upon it from any number of fixed points is 0. Okay, so a straight line is such that the algebraic sum of the perpendiculars, so one point is here,
Yeah.
This is P. One point is here. This is P1. This is P2. This is P3. This is P4. Like this, there are n points, right? N points,
Yeah.
right? A straight line is
Yeah.
such that the algebraic sum of the perpendiculars falling upon it from any number of fixed points, right, is
Yeah.
equal to 0, right? So algebraic sum means when you say perpendicular on from a point to a line, you do this: a1x plus b1y plus c by root a1 square plus b1 square, right?
Yeah.
But you put a mod because mod is actually the distance. It's cannot distance cannot be
Yeah.
negative, right? That
Yeah.
is why he has written the word algebraic sum. If you add the perpendicular distances, then they can never be equal to 0, no?
Yeah.
But if you add the algebraic quantity, the algebraic quantity is the one without the mod, right?
Yeah.
This
Okay.
could be negative or positive, okay?
Okay.
So he is saying that the algebraic sum of these distances is equal to 0, right? Correct.
Yeah.
So he is saying that let basically x1 y1, x2 y2, and so on till xn yn be the endpoints. Be the
Okay.
endpoints. Now, algebraic sum of distances upon this straight line is 0. So you will get something like a x1 plus b y1 plus c by root a square plus b square plus without the mod, okay, a
Yeah.
x2 plus b y2 plus c by root a square plus b square plus so on a
Yeah.
axn plus byn plus c by root a square plus b square is equal to 0, right? This is what the question is saying. Okay,
Yeah.
correct, makes sense.
Yeah.
Now he's saying prove that the line always passes through a fixed point. Prove that the line always passes through a fixed point, right?
Yeah.
Okay, so what we are getting is we can multiply the root of a square plus b square and remove that from this equation, no?
Yeah.
So you'll get a common summation of xi plus b common summation of yi plus n times c is equal to 0.
Yeah.
A common throughout, x1 plus x2 plus x3 still xn,
Yeah.
right? Similarly, b common throughout, right?
Yeah.
Makes sense.
Yeah.
Now, okay. So he's asking you to prove that ax plus by plus c always passes through a fixed point. Always passes through a fixed point. Okay. Uh, so can we get it like that? So generally, what the theory that we have learned is if any line equation can be written as p
X1.
plus
X.
lambda q is equal to 0, right? Where
Yeah. Okay.
lambda is a constant and p and q are the equations of the lines, right?
Yeah.
Then this line, this overall line capital L,
Yeah.
capital L always passes through point of intersection
Yeah.
of p and q, right?
Yeah.
This we have done in the last class, right? Previous class to
Yeah.
that. This makes sense, no? If you have an equation like that, then
Yeah.
it will always, the line L will always pass through point of intersection of p and q, correct?
Yeah.
So now let's try to one condition that we have is ax plus by plus c is my line. We have to get some result about this, right?
Yeah.
We have to prove that it passes through a fixed line. The other condition we have gotten is a into summation of xn plus b into summation of yn plus cn is equal to 0. But these are constants, right? These are fixed points, right?
Yeah.
Okay. So let's multiply the first equation to eliminate c. Let's multiply the first equation by n. So it becomes
Okay.
anx plus bny plus cn is equal to 0. So now we can just say cn. We can substitute from here. No, cn is equal to this, right? Minus of this and minus of this. So you get
Yeah.
anx. The equation of the line can be written as bny plus minus a summation of x
Yeah.
minus b summation of y. Correct?
Yeah.
So your equation is becoming x nx minus summation of xn, right? And a common plus
Yeah.
b ny minus summation of yn, right? Is equal to 0.
Yeah.
You're getting something like this. So
Yeah.
now here, if you notice that this is a constant, no, these are constants, right?
Yeah.
These are fixed points, no? So x1 x2 xn are fixed points, so that number
Yeah.
is equal, right? It's a number basically, right? So
Yeah.
now if I divide by a throughout, you get nx minus delta xn plus
Yeah.
b by a ny minus delta yn is equal to 0.
Yeah.
Now notice that this is a equation of L1 and this is equation of L2 and this is a constant lambda.
Oh,
See,
okay.
this is a straight line equation, no? Because x, a variable, is there and some constants are there, right?
Yeah.
And this is also looking like a straight line equation, no? Y is equal to
Yeah.
this, right? These are lines like this. These are lines like this and like this, right?
Yeah.
So clearly they will intersect at a point, no?
Yeah.
So what we have gotten this equation starting from here, right? We started from
Yeah.
here, and instead of c, I wrote cn like this, and then instead of cn, I put use this condition, right? The
Yeah.
condition which came from the fact that the length sum of the algebraic sum of the distances is equal to 0, right?
Yeah.
So now you are getting L1 plus lambda L2 is equal to 0. So
Yeah.
always is going to pass through L1 intersection L2, no?
Yeah.
Point of intersection of L1 and L2, and point of intersection of L1 and L2 will be summation of xn by n comma summation of yn by n, right?
Yeah.
See, x will be equal to summation of xn by n and y will be equal to summation of yn by n, so only one point will lie on both of them.
Yeah.
Correct. So
Yeah.
so your original equation, which has become and started looking like this equation, will definitely pass through this point, no?
Yeah.
So this is the point. So you have proved that the original straight line equation will pass through a particular point, and
Yeah.
uh, in this question you can take any perpendicular point. You can take p1, x1,
Yeah.
x2, x3, any point, right? As long as the condition on the sum of perpendiculars being 0 is satisfied, then you will have this type of situation where the straight line will always pass through the fixed point,
Yeah.
right? Okay.
Yeah.
Did you understand what happened?
Okay. Yeah.
Okay. Next one.
Um. Question 2.
Okay. Question 2. Two fixed straight lines OX and OY are cut by a variable line in the points A and B respectively, and P and Q are the feet of perpendiculars drawn from A and B upon the lines OBY and OAX, right?
Yeah.
So show that if AB passes through a fixed point, then PQ will also pass through a fixed point. Okay.
Yeah.
Okay. Okay. So, question 2. Two fixed lines, no? Straight lines
Yeah.
OX and OY. Straight lines OX and OY are cut by one other line. So let's
Yeah.
take O is here, X is here, and Y is here.
Okay.
Okay. So these are two fixed points. I will take one of the points as on the x-axis for making our calculation simpler, right? The other one
Yeah.
will be at an arbitrary angle. Right now we don't know that angle. Okay.
Yeah.
Now this is cut by a variable line P and Q, right?
Yeah.
So P and Q.
Yeah.
No. In points A and B, it is cut at points A and B by a variable line, right?
Yeah.
So let's say this is A and this is B, right? P and Q are foot of the perpendicular drawn from A upon the lines OBY, and OAX. Okay. So P and Q are foot of the perpendicular drawn from the points A and B. From A, if you drop a perpendicular on B, right?
Yeah.
This will be like what it will look like. This is P, right? And
Yeah.
from B, if you drop a perpendicular, this will be Q, right?
Yeah.
Correct. P and Q are the foot of the perpendicular. That also we got. Show that if AB passes through a fixed point, then PQ will also pass through a fixed point. If AB passes through a fixed point, then PQ will also pass through a fixed point, right? So
Yeah.
how will we do this? Let's say
What if we take OAB as a triangle, and then we can tell that AP and BQ are like altitudes, and then O to, let's say, point D will be the third altitude, and then we can tell like fixed point.
PQ will always pass through a fixed point. PQ, O to D. What are you think? O
Like
to?
one point on the, like O to D will be the third altitude,
Hmm.
and then we can tell that the
Let's call it
like
R.
where,
Let's call it R. Third one.
and
Then
then where PQ intersects OR, that will be like a one fixed point.
that is orthocenter.
Yeah.
That orthocenter is a point, but what do you have to prove? A fixed point on which line? PQ.
BA passes to a fixed point.
BA passes through a fixed point.
Yeah, like AB.
Hmm.
Then even PQ will pass to a fixed point.
Okay. So basically, he's saying that even if you change BA will always pass through one particular point.
Yeah.
Hmm. So let me think. Hmm. Let's say this is origin, right?
Yeah.
This point is, let's say, a comma 0. Okay. And let's say slope of this m is equal to slope of this will be tan theta or something. Tan theta of
Yeah.
this angle. Let's just keep it as m only. So equation of OPY is equal to y is equal to mx, right?
Yeah.
Correct. Now,
Yeah.
AB is a variable line. AB is a variable line that cuts OX and OY in A and B respectively, right?
Yeah.
So AB line could change, no? It could twist itself like this or like this and so on, right?
Yeah.
OX and
Yeah.
OY in A and B respectively. Now, okay. So coordinates of A we have already known. A coordinates are A comma 0, right? Right.
Yeah.
This B coordinates will be what? B could be B comma BM,
Okay.
because y is equal to mx, right?
Yeah.
Okay. So B will be B comma BM, and if the straight line AB always passes through a fixed point, say C, AB always passing through a fixed point, say C,
Okay.
right? Because the question says that if AB passes through a fixed point, right? So let's say that
Yeah.
fixed point is same, then slope of AC and BC have to be the same, no? A to C, B to C, right?
Yeah.
So what is the slope and all? So it will be okay. What I'm saying is slope of AC and BC are the same, right?
Yeah.
So slope of AC will be what? Y minus 0 by x minus
X
A
minus.
is equal
Yeah.
to slope of BC,
Slope of. Yeah.
right? So
Y minus BM by
hmm,
X minus B.
correct. Minus B and Y x minus B. So now if you multiply and all, right?
Yeah.
So you should get some nice formula. So for example, hmm, xy minus
Yeah.
by is equal to uh, xy minus by is equal to xy minus abm plus, so plus abm, hmm,
Minus XBM minus AY.
minus xbm minus ab,
Minus AY.
right?
Yeah.
So you will get an equation saying b into mx minus y is equal to
BM is equal to Y.
hmm,
I got BM is equal to Y.
hmm,
We can cancel XY from both the sides.
hmm,
And then if you group like those BM terms together, you'll
hmm.
wait.
B, group B is mx minus y plus is
Yeah.
equal to, you can say, abm minus ay, right?
Yeah.
Right. So
Yeah.
okay, equation of AP. So this was equation of which line? This was the equation of AB, right? No, this was
Yeah.
slope of AB, AC and BC, right?
Yeah.
Now equation of A to P would be perpendicular to the equation of OB, right? OB is that straight
Yeah.
line, right? So equation of AP will become OB equation was what? OB equation was or slope of OB was known, no? Slope of OB,
No.
O to B will be M, right? Slope of OB is just
Yeah.
M.
We are taking slope. Yeah.
Equation of AP then will be minus 1 by M. Slope will be minus 1 by M, right?
Yeah.
passes through y x passes through a comma 0. So y minus 0 is equal to minus 1 by m x minus a. My is equal to minus x plus a. X plus my is equal to a, right? Correct.
Yeah.
I hope
Yeah.
I'm not made some mistakes. My minus x plus a.
No, it's correct.
Okay. So you have found equation of AP.
Yeah.
Solving now AP and OB, right?
Yeah.
Right. So AP and OB, which is OB is y is equal to mx, right?
Yeah.
Solving this will give you the coordinates of this point P, no?
Yeah.
Correct. Now, if
Yeah.
you know the coordinates of point P, similarly, BQ will be perpendicular to OX.
Yeah.
BQ will be perpendicular to OX and it will be parallel to the y-axis. Correct. X is equal to B is
Yeah.
the equation of BQ, no?
Yeah.
If this point is at B comma 0 or this point was at B comma BM, then
Yeah.
Q is B comma 0, right?
Yeah.
Correct. So equation of line passing through P and Q. Now you can find equation of PQ, no? Because
Equation
we
of.
have gotten B and we have gotten this,
Yeah.
right? So PQ,
Yeah.
now you can easily find because P and Q we can find. P you can find by intersecting the two lines. P by
Yeah.
intersection of what? Of this PC
APN.
and OY, right? Or something like that.
Okay.
AP and OY. Yeah,
Yeah.
makes sense. So
Yeah.
once you do that, what happens is you get the point P, and if you get the point P, then you will be able to do what with it? You will be able to find the equation of PQ, right?
Yeah.
Because Q point is also known, right?
Okay.
Okay, these are slightly difficult, but the way to approach it is with a drawing. Draw a diagram, and once you
Yeah.
draw the diagram, what you should do is you should try to understand what is the given information given in the question and then proceed from there, right?
Yeah.
Till where have you reached in this exercise?
I'm currently on 19th one.
Okay, tell me other doubts.
14.
14. 14 is find the area of the triangle, that one.
Yeah.
So before 14, no other problems.
Like I have 3 and 4 as well.
Okay, let me just look at 3 and 4 once. If there is anything interesting, then I will ask. I will discuss. Okay, 3 and 4. Uh, third one is okay. Third one, let's do. It's a nice question. Okay,
Okay.
question 3. Uh, if the equal sides AB and AC, if the equal sides AB and AC of an isosceles triangle
Yeah.
be produced to E and F,
Yeah.
so that what is happening, BE into CE is equal to AB square, right? Show that line EF must pass through a fixed
B
point.
into CF.
B into CF is there. Oh, CF.
Yeah.
CF is equal to AB square. EF must pass through a fixed point.
Yeah.
Okay, so let's in this question, let's take some nice, choosing the coordinate axis is going to be very useful. So let's choose our coordinate axis nicely. Okay, so x and y axis will choose as two sides. Okay, AB and AC.
Yeah.
A and B. So we'll get coordinates of B as a comma 0 and C. A will be your origin.
Okay.
Okay, and B is a comma 0. Let's say this is isosceles triangle with length A, and C is this 0 comma A.
Yeah.
Right, now which two sides are produced? AB is produced and AC is produced, right,
Yeah.
to E and F, to E and F, such that AB is produced to E. So
Yeah.
B into E and C into F is equal to AB square. Okay,
Yeah.
so okay, AB is produced to E and this is produced to F, such that BE into CF is equal to AB square, right? So let's
Yeah.
say AE, the total distance is H. Okay, okay.
Yeah.
So basically E point is H comma 0, right? And this total
Yeah.
distance is, let's say, K. This point is 0 comma K. This is H comma 0, right?
Yeah.
So equation of EF line, right?
Yeah.
Equation of EF line can be written in intercept form, no? Equation
Yeah.
of EF will be just X by H plus Y by K is equal to 1.
Yeah.
Correct? Now, given condition is BE into CF. BE is what? BE distance is called H minus A into CF is called K minus A, right?
Yeah.
Is equal to AB square. AB square is what? A square, correct?
Yeah.
So, so what are we getting? We are getting HK minus AK minus AH is equal to 0, right?
Yeah.
Right? So AH plus AK is equal to HK, right? So
Yeah.
we get A by K plus A by H is equal to 1, right? Correct?
Yeah. But how do you get H minus A into K minus A equal to A square?
Because V into CA is equal to AB square.
Oh, okay. Okay.
This and this, right? Correct.
Yeah.
Now it is obvious that equation of EF, if you put A comma A point in this, then this is 1 and you're already getting that equation, no?
Yeah.
So that means this is like putting A comma A into the equation of the line EF, right?
Yeah.
So that means that A comma A lies on EF always, no?
Yeah.
A comma A always lies on E and F. Makes sense?
Yeah.
Only then you will get this second equation, no? A by K plus A by H is equal to 1.
Yeah. Okay.
So that means EF must pass through fixed point. Fixed point is A comma A.
Okay.
Okay. So how did we do it? We first set up our coordinate axis nicely, taking advantage of whatever is given in the question. So for example, here isosceles triangle and stuff, right?
Yeah.
And AB and AC were the fixed sides. So I chose A as origin, then the equation of EF became very easy.
Yeah.
We wrote it in intercept form. So we wrote your A comma 0 0 comma A and then found your E and F some point H and K, right?
Yeah.
We wrote the equation in intercept form and then we have been given a condition B into CF is equal to AB square. So that
Yeah.
just helps you prove that finally H by A by H plus A by K is equal to 1, where
Yeah.
A comma A is the point, right?
Yeah.
This is the third one. The fourth one, suppose if the straight line moves so that the sum of the perpendiculars from two fixed points is equal to 3 times the perpendicular on it from a third point, right? Prove that there
Yeah.
is another fixed point through which this line always passes. Okay. So first you will have to write the condition there. Sum of the perpendiculars is equal to 3 times the perpendicular from there, right?
Yeah.
So if you write the conditions, let's just quickly do this one. Question number 4. So
Yeah.
first condition that I will try to write is the equation of the straight line is ax plus by plus c is equal to 0.
Yeah.
Perpendiculars are dropped from 3 comma 4, so 3a by root a square plus b square plus the second
Yeah.
point is 7 comma 2, so 7a plus 2b plus c by, right, is equal
Yeah.
to 3 times perpendicular from 1 comma 3, so a
Yeah.
plus 3b plus c by root a square plus b square, right?
Yeah.
Correct. So you are
Yeah.
getting an equation. You're getting an equation. So you're getting 3
Yeah.
plus 7a, 10a minus 3a. So 7a. Then you're getting minus 3b, right? And then you're getting minus
Yeah.
c is equal to 0, right? This is the
Yeah.
condition that comes out from that original statement, right? Now you have to prove
Yeah.
that straight line always passes through a fixed point. So let's use the straight line equation ax plus by plus c is equal to 0 and use this fact that c is equal to 7a minus 3b, no?
Okay.
Right? So this becomes
Yeah.
ax plus by plus 7a minus 3b is equal to 0. You get 8 times
Yeah.
x plus 7 plus b times y minus 3 is equal to 0. Divide by a, so x plus 7 plus b by a y minus 3 is equal to 0, right? So this is
Yeah.
looking like L1 plus lambda L2 is equal to 0, right?
Yeah.
B by A is a constant, L1 is this line and this is this line. So it will always pass through the point of intersection of L1 and L2, which is minus 7 comma 3.
Okay.
It will always pass through point of intersection of L1 and L2, right?
Yeah.
Right. So as long as you get the equation of the line correctly, you will get everything else, right?
Okay.
You understand what happened?
Yeah.
Okay. So we have found the fixed point also, minus 7 comma 3. Now you were saying 14th one or something, right?
Yeah.
Okay. 14th one. Find the area of triangle formed by the straight lines this, this, and this.
Yeah.
Proving also that the feet of the perpendiculars from the origins upon them are collinear. Okay. The first area of the straight line, you can get
Yeah.
coordinates of the vertices, right?
Yeah.
So then after that, area is just simple after that, if you know all three coordinates.
Yeah.
You understand? You can
Yeah.
follow the shoelace method.
Yeah.
So eventually the area part, though, I think you would have done, right?
Yeah.
You are able to get the area, no, yourself.
Yeah.
Okay. So this is question number 14. You have been given 3 lines. You have to find the prove. You have to find the area, and also you have to prove that perpendicular from the origin upon these lines are collinear, right?
Yeah.
So let's write the lines. 3x minus 4y plus 4a is equal to 0. The other line is 2x minus 3y plus 4a is equal to 0. And then it is 5x minus 5 plus a is equal to 0. Right?
Yeah.
Solving the points, you will get 4a comma 4a, 0 comma a, and a by 13 comma 8a by 13. These are the 3 points that you will get. Okay.
Yeah.
Now, clearly area can be gotten like this.
Yeah. I got the area.
Okay, so you got the answer of 17a square by 26, right?
Yeah.
This is area. Now, perpendicular line perpendicular to this will look like what? Will look like 4y
Y minus like plus 3x.
is equal to some constant lambda. Let's say,
Yeah.
right?
Yeah. Lambda is equal to 0.
Because
If you
it
put
passes
0.
through the origin, right?
Yeah. Oh, okay. I understand. Okay.
Passes through 0 comma a. That's why, right? Wait, we have to find line perpendicular to that, and foot of
From
the
the origin.
foot of the perpendicular is from the origin. So lambda is 0. So one line
Yeah.
is 4y plus 3x is equal to 0. The other line here is 3y plus 2x, right, is equal to 0. And the third line is y plus 5, right?
Yeah.
5, wait, what have I done? Y plus
It should
5x,
be,
right?
yeah.
No. Mm,
No, it'll be 5y plus x.
5y plus x, no?
Yeah.
Correct. 5y plus x is equal to 0, right? These are
Yeah.
the 3 perpendicular lines, right?
Yeah.
Correct. So now you can find the foot of the perpendicular, no?
Yeah.
Hmm.
Yeah. Okay.
Foot of the perpendicular is solving which two lines?
The A, B, C, like which
So if
yeah, like
these
I
lines are
take
like this,
the initial one. I take
hmm,
the if I'm taking the 3x minus 4y plus 4a,
hmm,
then take 4y like 4x plus 3y.
hmm, something like this, you will get 3 lines. Now to find foot of perpendicular, solve this and this,
Yeah.
solve this and this, right? You'll find this point, and this point, right?
Yeah.
The answers are horrible, but it will come, right?
Yeah.
Now, area of triangle formed by joining the feet of the perpendicular, right?
Yeah.
Once you get the points, no, when you do the area should come out to be 0.
Yeah.
If area comes out at 0 for the feet of the perpendicular, right?
Yeah.
So then what it means is that
They are
the
collinear.
lines are collinear, right? 3 points are collinear, right?
Yeah.
Then only area of the triangle formed between them is 0, right? So to
Yeah.
prove collinearity here, you might as well take area here, area of the triangle formed by these 3
Yeah.
points, right? And
Yeah. Okay.
now it is just a matter of doing calculations. Okay.
Yeah. Okay.
Next one, tell me.
Like no other till where I am.
Okay. No other doubts till where you are, right? Okay.
Yeah.
So let's just do a little bit of theory. Let's go ahead a little bit. And then,
Yeah.
so this chapter, more or less, theory is done. You have to try practicing more and more questions. I don't think
Yeah.
any other theory articles are there. So
Yeah. Okay.
103, 104, these are all examples. Okay. And anytime you see an example where there is a angle which is oblique, no, coordinate axes are oblique, then you can ignore that.
Yeah.
Okay.
Okay.
Ignore the examples where coordinate axes are oblique. Okay. So
Okay.
now what we will do is some basic chapter 6 we'll start. We'll go till first exercise of chapter 6. Okay. So chapter
Okay.
6 is equations representing two or more straight lines.
Yeah.
Representing two or more straight lines. More straight lines. Straight lines. keep doing the questions one by one. Anything new you should try, and try to figure out everything that is there. Okay, don't skip
Okay.
anything. As long as it is not a repetitive thing, you should do it. Okay.
Okay.
So right now we'll start with Article 106. Article 106 of SL Loney. Here, he's saying that suppose you have to trace the locus represented by this equation, y square
Yeah.
minus 3xy. Suppose somebody asks you, what is this? Can you draw the locus of this? Or draw the graph
Yeah.
of this, right? Now
Yeah.
clearly this can be factorized, no? This will be y
Yeah.
squared minus xy minus 2xy plus 2x squared
Yeah.
is equal to, so y common y minus x minus 2x common y minus x. So this becomes y is equal to 2x or y is equal to x, right?
Yeah.
So this is clearly two straight lines, no?
Yeah.
So it's a combined equation of two straight lines. So you will draw it like this: y is equal to x is 1 and y is equal to 2x is 1. This is y is equal to
Yeah.
2x and this is y is equal to x. So this is the
Yeah.
graph of this figure, because clearly any point lying here will satisfy this, right? And any
Yeah.
point lying here will also satisfy this, right? Because
Yeah. Okay.
points lying on these lines will make one of the factors at least 0, right?
Yeah.
So this is like an equation of pair of two straight lines, no? Right? Two straight
Yeah.
lines equation this is, right?
Yeah.
Now notice one thing, one cool thing here is that if the equation of equation wait if the equation in x and y was homogeneous, what is the meaning of homogeneous? Homogeneous means this
Same.
expression has all the terms have the same degree. See,
Okay.
y square xy has 1 plus 1 degree, x is 1, y is
Yeah.
1, so 2, and 2x square has 1 plus 1 degree 2, right?
Yeah.
So all the terms have a degree 2, so this is called homogeneous. If you get ever a homogeneous equation, right, then
Yeah.
it is likely that it is a pair of straight lines.
Okay.
See, pair of straight lines passing through origin, passing through
Yeah.
0 comma 0. See here, there is no constant term also, right? So there is no constant term, so the equation is fully
Yeah.
homogeneous, right? Without any, every term is degree 2, right?
Yeah.
In general, when you have a straight line, one single straight line equation, right? You have a straight line equation
Yeah.
like this. Next page, y is equal to mx plus c, right? In general, right?
Yeah.
But this is not homogeneous. No, this is degree 1, degree 1, degree 0,
Yeah.
degree 0, and this is degree 1. These two, right? So this is not homogeneous. So if you multiply this y minus m y1 minus y minus m1x minus c1, multiply it with y minus m2x minus c2, right? If you
Yeah.
multiply these two equations, the resulting answer will also not be homogeneous. No?
Yeah.
Makes sense.
Yeah.
If it was an equation like this though, y is equal to m1x and another one was y is equal to m2x, right?
Yeah. Then it should be
Then it will be
homogeneous.
homogeneous. No? Then it will be y minus m1x into y minus m2x will be a homogeneous equation, right? So
Okay.
whenever you get a homogeneous equation, it is likely that it is a pair of straight lines passing through the origin, right?
Yeah.
Correct. So now
Okay.
this is article 106. Then article 108, he is going to consider the general equation. So let's look at 108. He is going to consider this general equation: ax square plus 2hxy plus by square is equal to 0, right? Correct.
Yeah.
So some in the previous question, remember that you were able to factorize it, right?
Yeah.
But it is not necessary that always it is easy to factorize, right? So it is better if you can get a general method of finding the equation of straight lines. So it is becoming 2hx into y plus ax square is equal to 0, right? This is a quadratic in y, no?
Yeah.
It is also a quadratic in x, but we'll take y for example. So y
Okay.
is equal to minus 2hx plus minus root over 4h square x square minus 4ab x square, right? By
Yeah.
2b, right?
Yeah.
This is what we are getting, no?
Yeah.
So y is equal to minus 2hx plus minus uh,
Yeah.
4 comes outside, so 2x comes outside, root over h square minus ab, right? By
Yeah.
2b, right?
Yeah.
Correct. So now this will be a pair of straight lines, right?
Okay.
This will be a pair of straight lines if, first of all, h square is greater than ab, right? If h square is greater
Yeah.
than ab, right? Like otherwise
Yeah.
this will be imaginary, no?
Yeah.
So
Yeah.
it will be a real straight line if h square is greater than ab. So you'll get y is equal to minus h by b into x plus 1 root over h square minus ab plus minus by b into x, right?
Yeah.
Like actually x can be taken common throughout, right? So you will get two
Yeah.
lines. Y is equal to minus h plus minus root over h square minus ab by b into x, right?
Yeah.
Correct. So in
Yeah.
general you are getting y is equal to m1x and y is equal to m2x, right?
Yeah.
Right. If h square is equal to ab, what will happen? Both the lines will be identical, no? Y is equal to minus
Yeah.
h by b into x, right?
Yeah.
In that case it is a perfect square, right? If h
Yeah.
square is equal to ab, you can write this one is root a whole square x square plus h square is
Yeah.
ab, so h is 2 root ab xy plus b
Yeah.
is root b whole square y square, right? So you can clearly see that this will become
Yeah.
root a x plus root b y whole square is equal to 0, no? So the
Yeah.
equation becomes y is equal to minus root a by root b into x, right?
Yeah.
And h was equal to root ab, so root a by root b, right? See,
Yeah.
are you getting it?
Yeah.
So you are solving this for y and you get this thing, and once you get this thing you can say that it will be a pair of straight lines if h square is greater than ab, and if h square is equal
Yeah.
to ab it will be pair of straight lines which are identical to each other, the same line.
Yeah.
It's one line only, but it has been squared and the equation is square of it, right?
Yeah.
Okay, so that is this article. When h square is less than ab, then there is no pair of
Real.
straight lines, right? No real
Okay.
straight lines, right?
Yeah.
uh, so see what he has written in that paragraph. In the case when h square
Yeah.
is less than ab, the straight
Yeah.
lines though themselves imaginary, right? They are themselves
Yeah.
imaginary, but they will intersect in a real point
Yeah.
because the origin will satisfy the original equation, no? 0 0 satisfies the original equation,
Yeah.
right? So
Yeah.
so they're straight lines, even though you cannot draw the graph and they're imaginary, you can
Yeah.
still say that they will what? They will intersect at 0 0, right?
Yeah.
So all the conditions of this we have understood. So basically ax square plus 2hxy plus by square is equal to 0. First of all, notice that all terms are homogeneous.
Yeah.
All terms are homogeneous. So that means all terms are homogeneous means pair of lines through the
Yeah.
origin.
Yeah. Okay.
Pair of lines through origin. And how to get the equation? Just solve for y. Y, make
Yeah.
it a quadratic in y, by square plus 2hx into y plus ax square. Solve this quadratic for y. So you'll get y is equal to something m1x and y is equal to m2x. Depending on two conditions, h square minus ab is greater than 0, you'll get this, right?
Yeah.
If h square minus ab is equal to 0, you'll get only 1, y is equal to mx. And if h square minus ab is less than 0, then no real lines, but just a point. 0, 0 lies on the locus.
Yeah.
Imaginary lines, but the point of intersection 0, 0 is real, right?
Yeah.
Correct. This is what is there till 109. Then 110 and 111 we will do. Okay. So now let's think of the opposite thing. Let's start from here, y minus m1x, y minus m2x, and multiply these, okay? So what do you get?
Yeah.
See, y square minus
Y square
m1 plus
plus
m2x
m2x.
plus m1 m2x square, right, is equal to 0.
Yeah.
So
Yeah.
now we started from this point and we got this equation, right? Now we can compare that with the original, no? Original
Yeah.
one is C, original one is by square and all, no? So I will make it like this, y
Yeah.
square plus 2h by b xy plus a by
Yeah.
b x square, right?
Yeah.
So original equation is looking like this and this equation is looking like this if you started with m1 m2, right? So clearly
Yeah.
this must be same equation, no? It's the same line, right? Same two
Yeah.
lines. So you should have the results m1 plus m2 is equal to minus 2h by b and m1
Yeah.
m2 is equal to a by b,
Yeah.
right? Then only it makes sense, no, that this can be factorized
Yeah.
like this, right?
Yeah.
Great. So now you know the slopes of the line. If this equation is given to you, you know m1 plus m2 and m1 m2, right?
Yeah.
m1 plus m2 is minus 2h by b and m1 m2 is a by b, right?
Yeah.
Correct.
Yeah.
If m1 plus m2 and m1 m2 are known, then you know m1 minus m2.
Yeah.
m1 minus m2 will be root over basically m1
M1
plus
plus
m2.
M2 whole square minus 4 M1 M2.
Correct. So once you know m1 minus m2, you can find m1 individually and m2 individually by
Yeah.
adding and all. Basically you can now solve for m1 and m2, no?
Yeah.
Okay. Now next thing that we can also do now is angle between the lines. Y is equal to m1x and y is equal to m2x, right? Angle between the lines tan theta is equal to mod of m1 minus m2 by 1 plus m1 m2, right? Right?
Yeah.
So
Yeah.
this is equal to root over m1 plus m2 whole square minus 4
Yeah.
m1 m2 by 1 plus m1 m2, right?
Yeah.
And this is equal to root over, okay, root should not have come overall, wait one second. This is equal to mod of root of m1 plus m2 whole square is m1 plus m2 is minus 2h by b, so this is 4h square by b square minus 4a, m1 m2 is a by b, no? 4a by b
Yeah.
by 1 plus a by b, right? Correct.
Yeah.
So this becomes tan
Yeah.
theta becomes 4 comes outside 2 root
2
h
by
square
B.
minus ab by
Yeah.
b and a plus b by b, right?
Yeah.
So tan theta comes as 2 root h square minus ab by a plus b, right?
Yeah.
This is the angle between the lines for the pair of straight lines. This,
Okay.
you understand? 2hxy.
Yeah.
You understand how we got it? It's very easy.
Yeah.
Because the straight lines you can get y is equal to m1 and m2, and then you can take the angle between them, right?
Yeah.
But now this is a direct result, right?
Yeah.
Now we can come up with results like this if h square minus ab is equal to 0, right?
Yeah.
Then tan theta is 0, right?
Yeah.
Then angle between the straight lines has become 0, no?
Yeah.
Then the angle lines are parallel.
Okay.
Parallel, and see, earlier we are getting this condition for identical lines, no?
Yeah.
When two lines have the same line, right? So
Yeah.
parallel means the same thing as identical, like at least in
Yeah.
terms of the slopes, right?
Yeah.
And if a plus b is 0, if a plus b is equal to 0, then tan theta is infinity, no?
Yeah.
So theta tends to
Yeah.
90 degree.
Yeah.
So the two lines involved in making this are perpendicular when a plus b is 0, right?
Yeah.
You are understanding?
Yeah.
So this is the 111 article number 111,
Okay.
right? Okay, then now 112, equation of the bisectors. Okay, equation of
Yeah.
the bisectors, just try and read yourself. I'm sure you will be able to understand it. Okay,
Yeah.
article 112 you can read yourself, and he has done
Yeah.
it in a 113. He has done it in a different manner also. Same thing, he has done it two ways. Okay, equation of
Okay.
bisector, and finally he gets an equation, nice looking equation, x square minus y
Yeah.
square by a minus b is equal to xy by h. Okay,
Yeah.
just try to figure it out. If you have any problems, we'll discuss it in the next class, if you have any problems in that bisector part. Okay,
Yeah.
so exercise 12 is now doable. Okay, and
Okay.
that will be our homework. So let's just write it, exercise 12 till exercise 12 of Loney. This is chapter
Okay.
number 6, and previous exercises 10, 11 and all you should see, and try to do as much as you can. Try to do as many
Okay.
questions as possible.
Okay.
Okay, as you can, and go slowly, but make sure that you understand everything. Okay, we are already quite far ahead of where we need to be, but I want to, by end of May, I want to like sort of like hopefully
Yeah.
finish circles, parabola, hopefully start parabola, ellipse and all. Okay, so
Yeah.
then we'll be good, because after straight lines and pair of straight lines, these four things are left. Okay,
Yeah.
circles, parabola, ellipse, hyperbola, these things. So once we do this much, we are done. Okay, with coordinates.
Yeah.
So we are right now in article number 112. We have reached. We have to go to article number 400. That is a lot. That seems a lot, but we have already done
Yeah.
30% almost. So 25-30%. We'll skip some articles in the middle which are not used, not necessary. But
Yeah.
but more or less, this is what we have to do. Okay. So
Yeah.
that's it for today. Make sure that you're working on these doubts, and next class we'll also discuss a little bit of physics. Okay. So
Okay.
keep doing your HCV also. Okay.
Yeah.
Okay, that's it. Bye.
Thank you, sir.